We live in an age of skyscrapers, tunneling machines, and GPS-guided cranes. We can print a house in 24 hours. We can lift 1,000 tons with hydraulic jacks. So it is deeply unsettling to admit this. There are ancient structures that modern engineers cannot rebuild today, not because we lack the will, but because we lack the how. Despite our technology, we cannot replicate the stone joints of Peru, the underwater precision of Japan, or the heat-proof masonry of Italy. These 5 civilizations did not just build big, they built machines out of geology, and every attempt to copy them has ended in failure. From number 5 to number 1, these are the civilizations that built the impossible, and we are still trying to catch up. Number 5, the Romans. Number 5, the Romans. You might think we understand Roman concrete. We do not. The Pantheon in Rome remains the largest unreinforced concrete dome in the entire world. It was built in 126 AD. The dome spans 43.3 meters. That is wider than the dome of St. Peter's Basilica, which was built 1,500 years later using steel ribs. The impossible part is the material itself. Roman concrete, or opus cementitium, has lasted for nearly 2,000 years in harsh marine environments, seismic zones, and freeze-thaw cycles. Modern Portland concrete begins to crack and crumble after 50 to 100 years. We have tried to replicate Roman concrete exactly by grinding the same volcanic ash, lime, and seawater. Our replicas do not last. Why? In 2023, researchers finally discovered the secret. The Romans used a process called hot mixing. They mixed dry lime with volcanic ash at extremely high temperatures, creating what are called lime clasts, tiny white chunks that give the concrete a self-healing property. When a crack forms, water enters, dissolves the lime clast, and recrystallizes into calcite, sealing the crack instantly. That is nanotechnology-level chemistry. We cannot mass-produce this. We cannot inject this into our dams or nuclear waste containers because we do not understand the exact thermodynamic reaction. Furthermore, the Pantheon's dome gets thinner as it rises, from 6 meters thick at the base to only 1.5 meters at the oculus. The Romans used 5 different aggregate materials, heavy basalt at the bottom, lighter pumice at the top, to control weight distribution without steel reinforcement. Modern engineers cannot pour variable density concrete in a single monolithic pour without formwork collapsing. Yet the Romans did it with wooden molds and human muscle. We have the Pantheon standing in the center of a modern city, and we cannot build its twin anywhere on Earth. The Roman Empire fell, but their concrete refuses to. Number 4, the Tiwanaku of Pumapunku. Number 4, the builders of Pumapunku in Bolivia. Located at 12,800 feet above sea level, this site has been called the most dangerous ruin for an engineer's sanity. The civilization known as Tiwanaku flourished for 500 years, then vanished around 1000 AD. They left behind stone blocks weighing up to 160 tons, but weight is not the mystery. Precision is. The stones of Pumapunku are made of red sandstone and andesite. Andesite is so hard that a steel chisel will dull after a few strikes. Yet these stones have cuts that are perfectly flat, with grooves exactly 6 millimeters wide and 3 millimeters deep. The tolerance across a 10-meter-long stone is less than 0.5 millimeters. We cannot cut andesite to that tolerance today without diamond-tipped CNC machines. But here is the true impossibility, the assembly. The stones are interlocking, 3-dimensional shapes, H-blocks, L-blocks, and U-blocks, that fit together like a jigsaw puzzle without mortar. To assemble one corner, 3 stones must meet at perfect 90-degree angles from different axes. Modern stone masons call this impossible geometry because you cannot slide the 3rd stone into place. It would lock before seating. The only way to assemble Pumapunku is to set all the stones simultaneously, meaning the builders had to pre-cut every single face with 0 error before lifting a single block. In 2014, a Japanese engineering team attempted to replicate one small H block using modern laser cutters and granite. It took them 3 weeks to cut the block. Then they tried to interlock 3 copies. The blocks did not fit. They had a 2-millimeter gap. The Tiwanaku had no iron tools, no wheels, and no written language. Yet they achieved fits so tight that you cannot slide a sheet of paper between the joints. We have the blueprints of Pumapunku. We have laser levels, and we still cannot replicate a single corner. That civilization is lost, but their tolerances are not. Number 3. The Olmecs. Number 3. The Olmecs of ancient Mexico. They are the mother culture of Mesoamerica, and they left behind 17 colossal heads weighing up to 40 tons each. But the impossibility is not the size. It is the carving method. Basalt is a volcanic rock with a hardness of 6 on the Mohs scale. It contains microscopic crystals of feldspar and pyroxene. To carve basalt with any precision, you need a tool harder than basalt, or you need abrasives. The Olmecs had neither. They had no metal chisels, no bronze, no iron, no steel. They had no diamond dust. They had only stone tools made of jadeite or flint, which have a hardness of 6.5 to 7. Wait, that is harder than basalt. So it is possible. But here is the failure. We have tried. In 2012, a team of experimental archaeologists took flint chisels and a 10-ton block of basalt. After 1,000 hours of hammering, they had created a rough, pitted surface that looked like a potato. The Olmec heads have smooth cheeks, defined lips, realistic irises, and distinct helmet straps. The heads are polished. How do you polish basalt without rotary tools? The answer is you don't, unless you have a lost abrasive technique. Some researchers suggest the Olmecs used sap from local plants mixed with quartz sand to sand the stone over decades. But a single head would require 500 years of sanding. Worse, the backs of the heads are as smooth as the fronts. That means the Olmecs carved a 40-ton stone in the round, meaning they had to flip it multiple times during carving. Flipping 40 tons without cranes would crack any stone. Yet not a single head shows stress fractures. Finally, the quarry. The basalt came from the Cerro Sintepec volcano, 80 kilometers away through jungle and swamp. Modern engineers have run the numbers. To drag a 40-ton head across that terrain using log rollers, you need 1,500 people and a road that is constantly rebuilt. The Olmec population of San Lorenzo at the time was only 2,000 people. That means half the city would have been pulling a single head for 3 months. No farming, no eating. The math does not work. The Olmecs built the heads, and we cannot replicate the logistics or the carving. They remain silent, 40-ton faces in the jungle. Number 2. The Yonaguni Monument Builders. Number 2. The unknown civilization that built the Yonaguni Monument off the coast of Japan. Discovered in 1985, this structure sits 25 meters below sea level. It is a stepped pyramid-like formation with straight walls, right-angle corners, a 5-meter-wide triangular pool, and 2 upright stone pillars that look exactly like a gateway. Mainstream geology insists this is a natural rock formation caused by tectonic fracturing. But here is why we cannot replicate it. If it is natural, then nature has accidentally done what human engineers struggle to do. If it is man-made, then a lost civilization built a stone megastructure that is now submerged. The impossible feature is the loop road. It is a circular, tunnel-like hole bored through a vertical rock wall. The hole is perfectly smooth and cylindrical, approximately 2 meters in diameter, with spiral tool marks inside. Those tool marks are identical to marks left by a core drill. Modern core drills use diamond bits and rotate at high speed. The Yonaguni drill marks show a consistent spiral pitch, suggesting a rotating tool with a fixed feed rate. No known natural erosion creates a cylindrical hole with uniform spiral grooves. Sandstone can erode into holes, but those holes are irregular, not smooth and circular. In 2007, a Japanese construction company attempted to recreate a similar cylindrical hole in the same type of sandstone using the best technology available in the Jomon period, which was fire, water, and stone hammers. They failed. They could not achieve a circular shape beyond 30 centimeters. The Yonaguni hole is 2 meters across. Furthermore, the monument has a stage with parallel straight lines cut into the rock that are spaced exactly 20 centimeters apart, the same measurement as ancient Japanese hand spans. The geometry suggests a planned blueprint. If this structure is 10,000 years old, dating from when sea levels were lower, then it predates the pyramids by 5,000 years. We cannot replicate Yonaguni because we do not know if it's architecture or geology. That uncertainty is the impossibility. A civilization built something so precisely that 10,000 years later, we cannot tell rock from a room. Number 1. The Old Kingdom Egyptians. Number 1. The Old Kingdom Egyptians of the 4th Dynasty. Forget the pyramids for a moment. The true impossibility that we cannot replicate sits inside the king's chamber of the Great Pyramid, a sarcophagus made of a single block of red granite. This box is 2.27 meters long, 0.98 meters wide, and 1.05 meters high. The walls are only 7 centimeters thick. The interior is hollowed out with perfectly flat bottoms and 90-degree interior corners. The impossible part is the drilling. On the floor next to the sarcophagus, archaeologists found a granite drill core, a perfect cylinder of stone that was cut out of a larger block. The core shows spiral grooves with a pitch of 2.5 millimeters per revolution. To cut granite with that pitch, the drill's cutting force must be 2,000 pounds per square inch. The drill speed must be constant, and the drill bit must be harder than granite. The Egyptians had only copper. Copper is a 3 on the Mohs scale. Granite is a 7. You cannot scratch granite with copper. The standard theory says they used copper tubes with sand as an abrasive, but sand cuts slowly and unevenly. To cut a granite core 10 centimeters deep with sand and copper, modern tests have shown it takes 500 hours of continuous rotation. But you cannot rotate a copper tube for 500 hours without the tube wearing down to nothing. The tube would vanish before the granite cracked. Worse, the interior of the sarcophagus is polished to a mirror finish. Polishing granite requires a sequence of abrasives from coarse to extremely fine, ending with a powder of aluminum oxide or diamond dust. The Egyptians had neither. The only abrasive they had was quartz sand, which leaves a dull, scratched surface, not a mirror. How did they get a reflection? In 2019, a team at MIT tried to replicate a small granite box using ancient Egyptian tools. They spent 18 months. The result was a rough, uneven box with walls 12 centimeters thick, twice as thick as the original. The corners were not sharp. The interior was not flat. They concluded that the ancient Egyptians possessed a machining technology that has been lost. We cannot replicate the granite sarcophagus of the Great Pyramid. We can build a skyscraper. We can land on the moon. But we cannot hollow out a granite box with 7-centimeter thick walls. That civilization is gone. The box remains. And every engineer who looks at it walks away humbled.